Cool. All right, so this was our instructions. We're going to create a node package, right? We all got that. Um, it's going to export a JavaScript class called paper, rock, scissors that will not take any arguments. Inside the class, there's going to be at least three methods. At least three methods: paper, rock, and scissors. When those functions are called, the player choice will be calculated against a computer choice, and each method will return win, lost, or tie. So when we call those functions, it's going to tell us if we won, or lost, or tied. And then there's some bonus stuff. We should be able to get through that. So let's copy all of this. First, we're going to go from GitHub. We're going to create this as a repository. And so I'm going to say paper, rock, scissors. Okay. Public. I'm going to add a readme, a get ignore. We're going to choose node here. And we create. Okay, now that we're up and running, I'm going to copy this. I'm going to create my program here. Let's see. Right, git clone and paste that link. Okay, so now we've got our module. I'm going to open this up. Open folder. Paper, rock, scissors. Save. Yep, perfect. All right, so now I've got, I'm like caught up, right? My GitHub project matches what I have on my computer. Everything's ready to go. But what I have to run now is npm init to turn this into an actual node project. Npm init. Okay. Paper, rock, scissors, good. Version 1. Cool. Index.js, that's fine. Git repository, Eric Harrison. And we're off and running. Yes, good. So I need to make my index.js. And we'll start from there. So I'm going to paste in these instructions as comments so that it will help us stay on track. Let's make this a little bit bigger. Good. And I'm going to press Alt-Z. Alt-Z will give it a word wrap. Cool. So create a node package. We did this. This is done. Paper, rock, scissors. Okay. The node package is going to export a JavaScript class called paper, rock, scissors. So let's just make a class. Class paper, rock, scissors. Okay. That's done. Inside the class, so let's copy all of this in there. All right. So inside the class, there will be at least three methods: paper, rock, and scissors. When those functions are called, right? So we're going to do paper, and we'll do rock, and we'll do scissors. Right. So at this stage, like we're mostly done with the entire thing of like we've set up the structure of our class. The only thing we would need to do is do exports.paper, rock, scissors equals paper, rock, scissors, right? We're going to export that class. And the reason we export that class is so that when we use this, if we were to go into node, for example, node, and we say let RPS equals require paper, rock, scissors. Cannot find module. That's unfortunate. We'll install that here in a second. Let's see. Oh, we can do it like this, I think. Let RPS equal require index.js. Right, so we can always require a script, right? We can say, hey, this doesn't exist in a package format that we can go and search on the internet for, either from npm or GitHub, but we can require a script. And so now RPS is that class that we just created and exported. So the way we use this, we say let game equal new RPS. Right? We could have called it paper, rock, scissors. What? Exports. Maybe we need to export it like this. Let's see. Let's exit out of here and try again. Node. Let RPS equal require index.js. Okay. RPS. Oh, we probably need to create a constructor. So let's do that. Paper, rock, scissors. Okay. Let's clear that out. RPS. Yeah, so we have to give it a name. Let's do module that exports here. should get us where we need to be. Exit. Node. RPS. Yeah, perfect. So now if we say let game equals new RPS, okay, game is that function, is that object that has, dot paper. Right? That's a function. Right now it does nothing, but we're like ready to go. It's up and running, right? And so Josh, when you were doing module exports is when you want to like export and control like what comes out of it. When we give it a name, like exports dot whatever, like we were doing the other day, that's when we're individually choosing what we're putting into the exports object. But when we say, hey, this entire package exports this class, we use module.exports like this. Okay, so inside the class, there's 3 methods: paper, rock, scissors. We got those. Player choice will be calculated against computer choice, right? And so if we were to call paper, right, this needs to return something. Return win, lose, or tie, right? So what I would probably do at this stage, and this is like from a software design point of view, right? All 3 of these functions are going to do the same thing, right? We have to get the computer choice, and then we have to decide, did the function that I called, right, either paper, rock, or scissors, did that function beat the computer choice or not? So rather than put all the code in each of these 3 functions where it's the exact same, I'm probably going to make a second function in here, and we'll make it, computer choice. That returns, paper, rock, or scissors. Okay? So I can say, let random choice equals math.floor, and then we'll do math.random times 3 plus 1. Plus 1, right? So this should return some random number between 0 and 3, right? So I can return that, and we can just verify that this is all working. Random choice. So let's refresh this object, and we'll say let RPS equals require index.js. Oh, shoot. Gave it an incorrect there. Dang it. I should make this var. Var game equals require index.js. Okay, so now game is our class, and we can say let var my game equals new game. Okay, so my game is now the instance of that game, and I'm going to say my game.computer choice, and let's just see computer choice, and let's see what, right? So 1, 3, 1, 2, 1. So it seems like it's working, right? We've got some random number between 1 and 3. Now we can go in here and we can assign, we can come in here and say, let choices equals, let's make it an object, right? So we can say, choice 1 is paper, choice 2 is rock, choice 3 is scissors, right? So we can say, let return choices, and then that random choice. Okay? And if we create a new one, or game, right? We say let var my game equals new game. Okay, so my game dot computer choice. Now, I have to exit out of this so that it will give me my thing again. Okay. Or my game equals new game. My game dot computer choice. Right. Now is going to return paper or rock or scissors based on that random number. Okay. So now we just have to say, if I am in here, right, I'm going to return, did I win or lose? Now, the way we wrote this before, right, was if, we need to get the computer choice. So we'd say, let comp choice equals this dot computer choice. Okay, so this is giving us that value in this function. So if comp choice equals, so paper, right? So if comp choice equals scissors, right, we return loss. else if comp choice equals paper, return tie. Else return win. Right? So we can do this exact same thing for each one of these functions, but what's probably more interesting for a class, right? We don't like code duplication. So what we probably want is we want to write this code in an agnostic way that takes both of these choices, win, the computer choice and the player choice, and returns if we won or lost, so that we don't have to have this for each of these things. Paper should just say, check to see if I won, paper. Rock should say, check to see if I won, rock. Right? So rather than having this code duplicated in each of these places, we can come up here and say, check winner, right? And check winner is going to take my choice, comp choice. Okay? So we can do the same thing here, right? So we'll say, if comp choice equals my choice, return tie. Return tie. Okay? If my choice equals scissors, if comp choice equals paper, return win, else return false, or loss, right? Because if we've picked the same thing up here, right? So scissors and scissors, it's a tie, and this exits out of the function. If we've picked scissors, we either win or lose, because the tie option is going to be taken care of right off the bat. So then the other thing we need to check is if my choice equals paper, if comp choice equals rock, return win, otherwise return loss. And then we do the same thing for rock. Else if my choice equals rock, if comp choice equals scissors, return win, otherwise return loss. Okay? So now each of these functions can simply say return this dot check winner, paper, and comp choice. And then we can do the same thing down here for rock. Oh, we need the choice here. Okay. And then here we do scissors. Here we do rock. So everyone see what we did here. We have the three functions that were required by the homework. We have to have a paper, a rock, and a scissors. But then rather than write the same code over and over and over again in each of our functions, we wrote one big function that checks to see if we won or not. Let me drag this down a bit so we can look at it. Right? So we're saying, hey, if the two choices are the same, it's a tie. Otherwise, if we're scissors, we win if the computer picked paper, or we lose. If we pick paper, we win if they picked rock. Otherwise, we lose. And honestly, we can even simplify all of this, right? Like, let's take out these else blocks, right? So these are how we win. If it gets to the bottom and we haven't already returned out of the function, return loss. Now we've made it even simpler. We check to see if it's a tie up first. Then we check our individual choice, my choice, my choice, my choice, to see if we've won or not. And if we haven't, we return loss. Okay. So let's go ahead. Yes.
Oh, I was just gonna say, so the way you're like making that code like tighter or more condensed, is that what makes it run faster?
No, not
No.
necessarily. I mean, it could run like taking out these else blocks and stuff doesn't make it necessarily run faster. But from a readability standpoint, as a programmer, like remember how I've been talking about getting in the habit of reading like from top to bottom just to get a mental picture of what is going on, right? Like this to me is cleaner code because I can read this and say, okay, I call this by saying, hey, paper is my function. I'm getting a computer choice. I can read what that gives us. Then I can return whether we won, lost, or right. So like the less lines of code you have to keep in your head, the easier it is to maybe follow the flow of what the program is trying to do, right? So check winner is the big function that matters. And so you can kind of see, because I picked pretty good variable names, my choice is me, computer choice is the computer. So I'm saying if they're the same, it's a tie. That's condition 1. Whenever you see return inside of a function, think like, okay, this can stop stuff from happening, right? If my choice is scissors and computer choice is scissors, right, it's going to return right here and none of the rest of this code matters. Think of this as like a break point. So, okay, we got ties taken care of. Then it says, if I pick scissors and the computer picks paper, I win. If I pick paper and the computer picks rock, I win. If I pick rock and the computer picks scissors, I win. Otherwise, right, it would have already left if we tied. It would have already left if we'd won. So all that's left is to say, hey, the default is losing. We could have flipped that around if we wanted. We could have made default be winning, and then we could flip these around. We could say, if I chose scissors and the computer chose rock, return loss. But now the functions that we actually use, right? This is how we play the game. I call this function. I say, hey, I'm picking paper. Do I win or do I lose? Is going to get the computer choice and return that. So maybe what I want to do to clean this up even more, I can make the computer choice not even be an argument. I could put this in here. And then each of these functions will simply call the check winner. Right? The whole point of making a class, or the whole point of writing functions, is to make your code cleaner. Part of this is that in the example you were shown earlier, Josh, your code was 100% correct, but you were checking roughly the same logic in each and every one of your choices, right? Well, now those functions are small and tight and tidy, and I've got one big function that is about the same size as the code you wrote in terms of like how many lines it is. But now it's structured in a way that makes it easy for me to play the game, or easy to read what is happening, right? So if we were to just let's verify this works, right? Node, and we'll say let paper rock scissors equals require index.js. Okay, that's step 1, and then we say let game equals new paper rock scissors. Okay, so now game.paper, I just lost this one. Game.paper, I tied that time. Game.scissors, I lost, tied. That time I won, right? So this meets the requirements of the homework, right? It returns a win, loss, or a tie. Now, we're over here dealing with words. Paper, rock, scissors. This is for our benefit, to let us know what's going on. The requirements of the actual homework here go a step further. Hopefully this will blow your mind. Okay? So when I call these functions, paper, rock, and scissors, those functions just say win, loss, or tie. And it's just using math.random, right? We did all this work to like figure out if we pick paper or we pick scissors. What if instead I simply said if, let's get a let choice equals math.random, math.random times 3 plus 1, right? So that's going to give us our random number between 1 and 3, right? What if we just simply said if choice equals 1, return win, else, let's put this on, let's spread this out a bit. Else if choice equals 2, return loss, else return tie. Right? It's doing the exact same thing now. This is valid code that meets the requirements. It's going to return win, loss, or tie. And we don't care about any of this, right? So let's do this. Take out this computer choice thing. So check winner. We could do return this dot check winner, or maybe we want to call this random winner, right? Because we don't even care what we picked. Random. Let's just copy this line so we can save ourselves some time. Huh? Okay. Much smaller bits of code here. Right? The computer is going to pick a random number between 1 and 3, and then we win just purely by randomness. Let's see if it works the same way. Let rock, paper. And then we say let game equals new paper rock scissors. Good. Game dot rock. Game dot rock tie. Oh, loss. So doing the exact same thing as before, but now we took out all the stuff that was like converting things to strings. We don't care if we threw rock, paper, or scissors. We're just gonna get, did you win with your choice or not? Now we've got a class that's really, I mean, if we take out, let's take out this, what is this totally? Like 20 lines of code? It's doing the same thing, right? Does this make sense to you guys? And what this has done is we've created a module that we can use in other projects. The whole point of this, the whole reason we made a class, the whole reason we made it as a node module is that when we get into web development, you remember earlier in the class we were building the paper, rock, scissors game a little bit, right? Like we could write this, right? Now we have something that we can reuse and put into a project to take advantage of this code that is already written, right? Let's take a look at the bonus question because I think those are pretty fun, right? Store the game results in a property in this class. Okay, so let's do a. Right, we can do this dot results equals right some kind of thing, right? So we can say what do we need to get here? Win, loss, and tie percentage. Okay, so let's tackle these first two to begin with, right? So we're either going to have win, loss, or tie. So we're going to say win, 0, loss, 0, tie, 0. Okay? And then maybe we'll do total. Okay? So we've got a results object that has win, loss, tie, total. So now, instead of just doing this, right, we can say let result equals random winner. We're going to get it, right? And then we'll say this dot results result, right? Because that's going to either be win, loss, or tie. Win, loss, or tie. Those are our three choices that can come back from this function. We're going to add 1 to it. Equals this results result plus 1. Okay? And then we're also going to do the total. Results total equals this results total plus 1. All right, we're always going to, every time we call a function, we're going to increase our total, but we're also going to increase our, whether we won, whether we lost, or whether we tied. So then we can get a, we still have to return result so that the function will be the same. So let's do this. Let's copy this down here. Copy it in all 3 places. Good. Cool. So now we're storing the results in this property. So let's make a function that will do like win percentage. So we'll say win percentage, and maybe we'll do loss percentage, and we'll do tie percentage. All right, so how do we find a percentage of something? If we've got a total and we've got a, right, so if we win one game and we've played 4 games, what is our win percentage?
25%.
That's right. The math for this is pretty easy. So we can just simply say return this dot results win divided by this dot results total, and then we probably want to like times it by 100, right? So we don't get 0.25. We want to get 25%. So let's just do this. All right. So that's our win percentage. Do the same thing with loss percentage and tie percentage. Let's say tie, loss, and we could say tie. Okay. So these are doing the adding. Every time we play a result, we either win, lose, or tie. It's going to store that result in here, and then it's going to increase the total. So if we were to test this out now, we got 3 new functions to play with. So let's node. Okay. Create a new game object, and we'll say game.paper. Cannot read property loss of undefined. We got an error in our code. Line 40. Line 40. So this results, did we name our thing? Yeah, this results. Let's move this out. Results? That maybe? I always forget this. I don't use this ES6 syntax very often. Let's see. Node. Require. Call our game object. And let's play. Let's take a look at the results. Oh, yeah, okay, perfect. So that was what we needed to do. So we got 1 win, 2 losses, 1 tie, 4 total games played. And so now we can call game.win percentage 25%. Loss percentage 50%, tie percentage 25%. Let's just keep playing. Right? We should over time expect this to be roughly like 30 30 30, right? 33 33 33. Right? Game.results. Yeah, and we're getting close. It seems like it ties more frequently than right, so it seems like in our random number generator, 3 is coming up more frequently than 1 or 2. But, that's fine. If we ran this 1,000 times, the more times we run a random number generator, the more frequently it will approach the statistical average. But now we've got percentages. Then number 6 says even more bonus. Create a method or methods that will return statistics, win percentage, loss percentage, tie percentage by choice. So in order to do this, we'd have to store each individual choice in some kind of results data object, right? So we'd have to say, results by choice, and then we'd want to have paper, same kind of data object, win, 0, loss, 0, tie, 0, total, 0, and we'd want to do the same thing for all 3 of them. We got to put commas after this, comma, let me call this rock, scissors, okay, and then we'd want to do the same thing. So it'd be this dot results by choice, and then in this case it's paper because we're in the paper function, and then we do result, and I also need the end quote there. And I'm just going to do plus plus. You guys realize that plus plus after a number is the same as doing equals the same thing plus a number, or plus 1. So this is kind of the shorthand for this. I'm going to do the same thing here for this results by choice, paper, total, plus plus. Okay, so we need to put both of these lines of code in each of these functions. Okay, and then we change this to rock, Change this to rock. Change this to scissors. Okay. And now, if we reload our code, there we go. And now if we do game.paper, call this a couple times, right? We haven't written a function for this yet, but we could. It would be similar to this, right? Win percentage. Maybe we'd want to put in, an argument in here, like choice, right? So if choice is something, we'll return the win percentage by that choice. Okay, so let's just take a look at game.results by choice. So paper had 7 wins, 8 losses, 4 ties, for a total of 19 total games. So let's rewrite these functions, right? So this is the default. If you don't provide a choice, give me my current overall value. But if choice is provided, we're going to return this same thing, but from the results by choice. Results by choice. And then we put in the choice. And results by choice, and we put in the choice. So it's the same logic, but now we're saying if we provide a choice, return that to me. Let's load this up and see what it does. Require our module, create a new game object, game.paper, game.paper, game.paper. Just call this a couple times, good. And then we'll say game.win percentage, right? 31.25. If I was to put in paper in here, it's going to give us the same. It's going to give us the same value because all we've ever played is paper. But let's say game.rock. Let's call game.rock a couple times. And maybe game.scissors a couple times. So now game.result win percentage. Right. Overall, we're at 29% win rate, with just in general. But if we look at it by game.win percentage by paper, it's 31.25. By rock, it's 27. And by scissors, it's 30. Okay? This is the power of writing a good class or a good function. It's very, very easy for us, with just applying a few simple rules logically, to add new features, new functionality. All right, we start with the easy one, like let's check our overall results. Each of these functions just needs to add some counter in there to let us track some statistics. Then when we want to add, extra features, right, we can just make another data object that breaks those same values down by the choice. Any questions here? Go ahead, Grief.
So using this module, you would only have, if you're using it on another website, like you use the modules for separate websites, you create it once so you don't have to duplicate.
Correct.
You would only have to have, 3 objects in that website, or you can use it for multiple objects in a website. Let's say instead of paper, scissors, rock, you use a dice or die, which has 6 sides.
Yeah. I mean, if we wanted to make a whole game of it, so there's 2 schools of thought, right? Maybe this is a big game of chance class that has a paper, rock, scissors class object inside of it, or maybe it has a dice thing inside of it. We could do that. It's up to us and how we want to write our code. So I like to have classes that are kind of small and tidy like this, where it does one thing. And if I'm going to play paper, rock, scissors, I'm going to create an instance of that, calling the new keyword, right? This is what actually creates this object. Let some variable name equals new, and then the class name. So I would probably create it like this, but I could have also made a bigger video game class that has a whole bunch of games inside of it. There's no right or wrong answer here. It all comes down to what is the cleanest looking code. And if I was going to build a game website, for example, and I wanted to write all these modules, rather than tracking the statistics of the games in here, I might make a statistics class that all of these games inherit from. So I can say, hey, when I play paper, rock, scissors, if I pick rock, I get this total value. And so then all I'm doing in here is saying like, this dot statistics dot store result. So it lets us break down the complexity of our code. So remember when we started with this, the bare minimum implementation of this was like 30 lines of code. Now that we're adding statistics in here, right, we can see some opportunities for improvement, right? This same 4 lines of code is in each of these paper, rock, and scissors. And even like 67, right, where we're getting the result itself. That's the same. This is the same line of code. So I would start to think of ways to, okay, like let's improve this. Let's make it so that I don't have to have code duplication. Right? Because this is where, as a software engineer, when you start to see things repeating like this in your code, this is opportunities for things to go wrong very subtly. And by that I mean, like, if I had put in here like pape, okay, everything would work except I would get very bad statistics from the paper win percentage if I called win percentage and put in paper. Everything else would be right, but the numbers coming back from paper would be wrong. So it makes opportunities for you to have errors that are really hard to spot and track down. Like, this is valid code in JavaScript. This is valid code. So it would not throw any errors. It would not warn you. It would just silently start counting results by choice pape total plus plus.
Follow.
So, part of why we use classes, part of why we write node modules like this is so we can take any kind of concept in programming we want to implement, like a paper, rock, scissors game, put it in a small, self-contained, neat little package, and reuse it over and over and over again. And as we need to add features, as we need to increase the complexity of what we're doing, it gives us more opportunities to write better, cleaner code that makes it clear what's going on. What I would probably do here, because this random winner function is kind of magical, I would maybe just say, like, this whole game, I'd maybe comment this. Be like, paper, rock, scissors has a randomly chosen winner from a random number between 1 and 3. Okay? But this right here is probably the most naive version of paper, rock, scissors that has ever been built. So maybe what I want to do to make the game more difficult would be to say, hey, whatever the player threw last time, whatever their last choice was, maybe there's a 50-50 chance that instead of a random number on the next one, the computer picks what would have beaten their last thing, right? So that every time I pick paper, right, if I throw paper and I beat the computer throws rock, the next hand, the next time I play, there's a 50-50 chance that the computer is going to pick scissors, so that it has a higher probability of winning if I continue to play the exact same strategy. All of that is really easy to do in programming that make it possible for us to build really cool interactive applications, right? This is a game, and the reason we pick games like this is it's really simple to explain. Everyone understands how the game works. Dice would be another great one if you're like, throwing snake eyes or whatever. What's another good? Heads or tails, where you're just guessing. Is the next one going to be heads or tails? But we have a lot of opportunity in this one single function to make our game better and more difficult. And maybe what we do is when we create this object in the first place, maybe this takes a difficulty level, right? And so by default, our difficulty level is easy, where it's just a random number generator. But maybe if we make it medium or hard, it tries to predict based on our previous, like if we make it hard, maybe we store all of the player's choices, and we make it so that the computer tries to predict what you're going to throw next based on your past 5 throws or something. So we can swap out functionality on like our game logic. We have all of that is up to us as programmers. But this is like if I was building a website or a game where I really wanted to like have it be a real game, I would start with something like this. I would start with the bare minimum, like let's make it just function. Let's test it out. Let's make sure it works. you see me. This whole time I'm writing code, I'm in here in my console testing my object over and over and over again. I want to make sure that it works. I want to play with it. I want to experiment. Okay? And then, once I get to a happy place, now I start thinking creatively. This is the fun part of programming, where we get to pick solutions. We get to invent, how hard is this game going to be? What is the expected... if I pick paper every single time, by like throw 3, the computer should start always picking scissors. Right? Why would it pick anything else if I'm always picking paper? So what kind of code can you write that will get you to that point? Okay. So now this code is good. It meets all the criteria of our homework. Right? Maybe the only thing that is technically incorrect, because it gives you an example here in the instructions, is that paper rock scissors dot win rock returns 24.5. Well, I called this win percentage, not win. So if I was trying to follow specifications in the homework, I would go back and rename these functions: win, loss, and tie. And then the other thing is this says, hey, this returns 24.5, and then the percent sign. So maybe I need to include, a percent sign in here so that it shows up correctly. Plus percent. And then I need to change this to tie. Oh, and I have to do it for here as well, right? Plus percent. So now I've completely followed the exact specifications of this program, of the instructions. And sometimes in software engineering, like the attention to detail part matters, right? If you're building flight control software for NASA and they want you to return, some angle of attack from 0 to 90, right? If it's possible for your software to return 91, well, you just caused a rocket to possibly explode, right? So like attention to detail is extremely important in this profession. So now I've satisfied all of our requirements. Any questions?
Your loss return needs to be lost. You typed tie by mistake.
Did I? Oh, this says win. Yeah, this says loss. Yeah, look at that. Tie. Loss. Yeah, see, that's a problem with copy and pasting fast. Win-win, loss, tie. Good catch, Creef.
That's the thing. I can read it, but the problem comes in when trying to think of a way to do it the way you're doing it. Like, okay, I can shorten this. I can abbreviate this. That's my struggle.
Mm-hmm. And that just comes with practice. The more software you write, the better you'll be. We have a lab time in this class that is from noon to 4. If this was me, if I was in your shoes, I would spend noon to 4 writing code. Because when I was learning programming, I would wake up before school, write code, go to school, take computer programming classes, write code, come home from school, write code, and then in the evening write code. I was writing code all the time because the joy of what I was creating was super exciting. You feel like a superhero. You're typing things and the computer is doing what you tell it. When you're a software engineer working in your day job, you're going to have 8 hours a day just to hopefully write code. Focus on building cool things. The more code you write, the better you're going to get. I'm sure you guys have heard this. It's like from, I don't know, I forget who writes it, but the thing is it takes like 10,000 hours of intentional practice at something to become an expert or a master. The same is true with programming. The faster you can get to 10,000 hours, the better. Okay? We're not trying to get you to be a master. We're trying to get you employable as a junior. There are 2,080 working hours in a year. So it's going to take you 5 years to become a master if you get a full-time job working as a software engineer. But if you work as a programmer and your 80 hours a year is employed as a software engineer, and you spend time on nights and weekends building stuff for yourself, whether going to hackathons or building projects for yourself, well, now you're going to be at 4,000 hours or so after the first year, and now you're more valuable and more employable than any of your peers that are starting at the same time. I never went to college. I got a job as a programmer in the Army, working 8 hours a day writing software. When I got out of the Army, I had 5 years of programming experience on the job, when all of the people that were just now starting to graduate college from my high school had 0 years of programming experience, just the stuff they got at whatever university they went to. For those of you who have taken some college programming classes, you know how thorough and useful those are, right? So I pretty much entered the job market as a senior software engineer. The more programming you can do, the better. And the more practice you get at this, I promise it starts to click, and you start to, you'll look back in a year and you'll be like, holy moly, I'm writing some pretty good code now. But there's always new stuff to learn. There's always new stuff to explore. And that's why I would encourage you, spend your free time building things. Go to hackathons, meet up with other software developers, and just build stuff you care about. I guarantee you will probably get a job working as a programmer somewhere that's boring. You'll be building websites for agents and clients, and you'll build a restaurant website. You'll build 10 of them a year, and you'll be like, this kind of dull, right? But on your free time, maybe you're building a roasting app. Maybe you're building the next Flappy Bird that makes $45 million in a month in the App Store, right? Flappy Bird is like 3,000 lines of code and like a really crappy art asset and some Mario tubes, right? The programming is not the hard part. It's being creative with what you want to program. Any questions? I'm gonna check all this in.
Oh, and that 10,000 hours to master.
Yep.
That's Malcolm Gladwell.
Malcolm Gladwell. Thank you. Gosh.
From the book Outliers.
Yeah, Outliers. Yep, it's a great book, and
yeah,
it's like a good rule of thumb. Like you can obviously get, because like one of the things that is missed is that it's the 10,000 hours of intentional practice, right? You're like doing it on purpose, not just like playing basketball for fun, right? But working on drills, working on free throw drills, working on 3-point drills. It's like the intentional act of trying to be better will make you a master. And that's just, kind of plus or minus 5,000 hours, right? Programming is the same way. This is a creative art form. We are typing words. The words we get to pick are completely up to us. It's like being an author or being a poet. But our words, when we write them, a computer actually makes things happen. So it's one part art, one part science. Okay, cool. So we built a module now that plays paper, rock, scissors. Let's take a break. When we come back, we're going to dive into a new Node.js module and really kick off the rest of, hopefully, the rest of the course, which is we're going to start building web servers using Express. Okay? So it's 4:56. Let's come back at 5:10.
Hey, Eric, really quick. I don't know if it's just me, but you're coming in a little choppy.
That's unfortunate.
I didn't know if it was a me thing or I should ask that before everyone left.
Yeah.
I think it's you.
Yeah, I think it's you.
It's me? Okay.
Yeah.
Get better internet. It's probably because you're using Firefox. The internet knows you're using Firefox. They're mad at you.
Probably. Okay.
Cool. So the first thing we do before we're going to dive into Express, which we'll do later today, is we're going to look at one of the other ways that we can. It's kind of like the down in the dirt, bare metal version of building an HTTP server. When Node first launched, this was the only way to do this until Express was released. Okay, so I'm going to pull up a console here. We're going to do this all from the REPL. So Node, right? So there is a package, there is a module called HTTP. Now, with this module, we can do all the things we're going to show off building a server, but we can also use it to make requests on the internet. So on the front end, we learned about the XML HTTP request object that lets us make requests to other servers. The HTTP server on the Node side is kind of like an all-encompassing, all-in-one way to both serve requests for HTTP and send requests for HTTP. But we're going to take a look at the handling of the request version to begin with. So we're going to say let HTTP equal require HTTP. Okay, this gives us the HTTP object. Okay, so now to make this work, right, we're going to say let server equals create HTTP.create server. Okay, and it takes a callback, so it's a function that has a request object and a response object. Okay, and then it does something in here. So let's have it just console.log rec, and then we'll say res dot write. Well, we'll just log the request to begin with. Okay. So now I've got this server object, right? But right now it's not doing anything. Okay. We've created a server. We have to tell it what port to listen on. So we would do that by saying server dot listen, and we give it a port. So in this case, I'll do like 5,000. Let's do 8080 or 8888. Right. Okay. So now I've got a server that's running behind the scenes. So if I go to localhost and I go to 8888, okay, it's going to handle that request. Okay. Now, it is going to handle that request until we send the response.end object. Response.end. This is what it's saying. Hey, close the request. So we would have to recreate this. Let's actually do this in a let's do this in a code editor so we can make some changes real quickly. New window. All right. I'm going to open a folder, CBC13, and I'm going to say new. We'll call it HTTP object. Okay. Right, so in here, I need a terminal, and we are going to say npm init. Turn this into a node project. Good. 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 Yes. Perfect. So index.js. Let's make that index.js. So just to reiterate, just to go over this again, let HTTP equals require, and we call it the HTTP object. Now, we don't have to do npm install. The HTTP object is a part of the base installation of Node. So anywhere Node is installed, HTTP object is this package is already ready to go. And we do let server equals HTTP dot create server, and it has a function as its thing. It has the request and it has the response. Okay. So if we do console.log rec, that's going to log the request information to us. And if we do res.end, right, that closes the request. Okay. So if we were to run this now, node index.js, right? Oh, I forgot to tell it to listen. Right? So we created our server. We need to say listen on port 8888 or whatever port we pick. So now if I run this code, okay, you'll notice that it's running. I've hit node index.js here. This code is going to run forever until we close the program with Control C or Command C. So while this program is running, we have a web server that is running behind the scenes, listening for a request. So if I hit enter here, right, now you see that we get that console.log of the request object. Right? This request object has a whole bunch of information here. What was the URL that we requested? Right. So if we do instead of console, let's console.log rec.url as an example. Let's close this server and restart it. So if I call localhost, right, it's saying, hey, the first request is to slash. Then you'll notice that it also sent a request to favicon.ico because our browser is trying to see if there's a site icon to go with this website. Okay, so those are the two requests that we're going. If I put in a request to, /user/Eric, right? The request is /user/Eric. Okay. This is how we had to write HTTP code to begin with, right? We would get this rec URL, and then we would do something like switch rec.url. We'd maybe do case user. We would say something like res.write, hello world. Okay. Break. So for each path that we wanted to serve content from, we would have to write, some route for it. And we're still going to have to do this when we get to Express. We start learning about the Express framework. But this is like kind of the old-fashioned way, right? And so if I go to rec/user, I have to close and restart my server. It's going to send hello world. So all the content that we want to send, we are responsible for sending it along, right? So if we wanted to make it so that this could serve HTML pages for us, we would have to combine this module with the file system module and say, hey, read this file. See if this file exists. If it does, read the file and send it to the user, and then end the request. We would be responsible for each and every part of this request. Does this make sense to everybody? Okay. Yep. Yeah, I mean, generally, we don't often use this HTTP module for this purpose anymore just because it's too cumbersome. It's not well suited for building a scalable web application. There are better HTTP frameworks, and we're going to go over Express here in a little bit, that make this way easier. But this was kind of how we did things for a little while. We would be responsible for every little bit of code that we wanted to have the server act on and perform. Any questions? Yeah, go ahead.
So if you go back to that, so the server, the http.create server, the function inside there, that's getting called. The request is getting called when you go to the website or to the port that you designated.
Server is creating the actual server. This function is called each and every time a request is made to that server. So
is that?
Yeah, go ahead.
Is that a callback?
Yes.
Is that a callback function? Okay. Okay.
Yep. And we're using the request, right? The request object tells us information about what the request was, right? So rec.url is like the page I asked for. Rec.hostname tells me the IP address I'm coming from. Like, this object is full of anything that, it's going to tell me my browser. It's going to tell all these things that were a part of the request that my browser made to the server. And then the response object here is us communicating back to the user. So it's got this connection that starts from the time I make a request to it all the way up until it gets a response.end. Response.end says, okay, I'm done sending stuff back to the user, close the connection. But the server is still running the whole time.
Okay. So the server's listening on port 8888.
Yep.
You don't have to specify, like, once we get a URL, like, hey, this server is listening on www.whatever.com port 8888.
I don't understand the question.
So it's listening on, this server is just listening on port 8888. But, like, if I was a user, like in a real scenario, how would I get to, like, that website or whatever?
Yeah. So the address to this website is, currently localhost port 8888. Now, the default port for web is port 80 for regular unencrypted HTTP traffic and 443 for SSL. Right? So most websites are SSL now. It's port 443. The reason we develop on our computers with, like, high ports like this is because on a server, right, the ports 0 through 1024 are generally protected. You have to be a super user, root account, or somebody that has permission to create a server touching those ports. So when we deploy our code onto, like, an actual server, right, the root account will have to run this, or some super user access where we've set permissions to allow them to touch this port, and then this would be like port 80 or port 443. Okay. The way we would generally do this is with, like, an environment variable where we'd say something like let port equals production port 80, otherwise port 8888, right? So every time I run this, right, it's going to pick the right port based on what environment I'm in. If I'm running on my computer, it would use 8888. Otherwise, it's going to use port 80, right? And that'll be something like let production equals false, right? And then we would put port in here. So we're actually going to, in like a week or two, we're going to learn how to deploy this code to a service like Heroku. They're going to have the steps that they expect for you to write, what port they're going to expect you to listen and respond to requests on. I think they use like 5555 or something like that. I always have to look at their documentation. So that you can appropriately respond to requests when the user, because the user, whenever you just type in google.com, for example, you're actually making a request to port 443 because Google is encrypted. Okay? We're writing just the server software, and we're telling it what port to run on, but this will generally be set by some environment variable set up by a system administrator or somebody that's on your team responsible for deployments.
And then so you buy your URL and then just place this on top of that? Is that how that works?
Yeah, I mean, so that's a completely separate system. The DNS mechanism just points to an IP address, right? So when we buy ericharrison.info, right? I'm going to set up in my DNS server, ericharrison.info is hosted, right? If somebody goes to ericharrison.info or www.ericharrison.info, it resolves to this IP address. So when somebody types in their browser, ericharrison.info, DNS says this is the IP it's at. The browser by default, if we didn't include any port in our address request up here, it's going to assume port 80 or port 443. Generally, what you'll see if you go to like a regular website, like if I type ericharrison.info, the first request is actually to ericharrison.info port 80, and then my server is saying, "Thank you for your request. Please redirect to port 443." So it silently behind the scenes has redirected us to the HTTPS version on port 443. That's happening on my server. That's a server configuration thing. The domain name itself doesn't care what port I'm on at all. I could run a server on ericharrison.info and run literally this exact same code and tell it, hey, listen on port 443. Now, listen on port 8888. ericharrison.info :8888 would respond with this server handling the request.
Okay.
Does that make sense?
Yes.
Okay. We're not going to spend too much time talking about the HTTP object specifically. We just want to show like this is an object, a module that you have available at your fingertips to make simple web servers, right? We might use this for an API or some kind of like, is my light switch on, right? This is a very lightweight module that exists in all of Node that can handle and respond to HTTP requests, right? So if I was trying to build something simple to like interface with some hardware, right? If I had like a little tiny Arduino or what's that other one? Raspberry Pi, right? I might use this server to respond to very simple requests like turn the lights on or off if it's attached to some hardware, right? Where I don't need the server to be complicated. I don't need all this request parser stuff. I just want it to say on or off, right? And so we could do that, right, as an example. Let's do that. Let's change this. Let's take our step. Let's turn this back to 888, right? Good. So let's say let light switch equals on. Let's make it off by default, right? And let's say when I go to switch, okay, it's going to light switch equals light switch equals off on. So it's gonna change it or off, right? We're using the the ternary operator. So if the light switch is currently equal to off, we're going to change it to on. Otherwise, we're going to change it to off. So it's going to just go between off and on. And then instead of res.write hello world, we're going to write light switch. Right? So if I close this server now and I restart it, now what I've built is a simple, in like 15 lines of code, light switch controller, where every time I reload the page, it's going to flip it between on and off. Okay? The HTTP module is very small and very efficient. When we start building actual web applications, we're going to use a module called Express. And we were playing with this a couple days ago when we were looking at modules. Express comes with a whole bunch of other packages. It's got like URL parsers and cookie stuff. All of that is super big. If you care about speed and performance and like being as small as possible, and you're just trying to do something super simple, that's what that's what this module is for. Something super tiny and lightweight. Now, the Express module, the one that's like this full-featured, really robust library that we're going to use, behind the scenes is using this module, right? When it actually makes a request. So there's nothing preventing you from using this module. This module is extremely powerful, but this is like for building something really efficient, right? So if we wanted to make an off light switch light switch. Right. We can write very lightweight little applications using this. Case on. Stop right. And switch. And maybe what we want to do is whatever the state of this on or off is, maybe instead of just responding back with the thing, we may put in some HTML in here, and we say body style equals background color. We either want to make it like black, right? So let's do let color bg color equals FFF. Let's make it black by default. 000. Let color equal FFF. Right. So So if light switch equals off. Wait. Let's do this for each. Right. So we don't have to put it in each thing. Right. So if light switch equals off, we're gonna make bg color equal 000, color equals FFF, else bg color equals FFF, color equals 000. Okay, and then as a part of this request back, we're going to use like some invalid HTML here. We're just going to send a body tag so we can show this off. We'll say plus bg color plus color plus color plus. Okay, and then we'll at the end of this we'll say close our body tag plus body. Okay. And then we'll copy this in both places. So actually what we can do, since all of these choices are going to output the same thing, right, we can just display that here, right? All we need to do inside of our switch statement is change the value. And we probably need to put this, right? So if we've changed the value, we're going to put this down here so that our background color changes. Okay. So what we're doing here is we're saying a request comes into our server. We're checking the URL. If it's switch, it's going to toggle between on and off. If I send it to /off, it's going to force it to off. If I send it to on, it's going to force it to on. Okay. And then we're saying, hey, if it's off, I want to have a black background and a white font. If it's on, I want to have a white background and a black font. And then we're outputting this HTML. Okay. And we can make this real HTML. HTML. If we wanted HTML, we'll skip a title for now. HTML. Okay, so this is like minimum valid HTML. Alright, so let's restart our server. Okay, and if we go to switch, on, off, on, off, on, off, and we can say, hey, force it to on. Alright, that's always going to make it on. This is always going to make it off. And switch. Right, so this is what level of complexity you should expect for using the HTTP module, right? Just outputting some very generic HTML. Any questions about this? It can do so much more. We can send headers with this module. We can make requests to other servers with this module. So if you were wanting to write like your own API reader and you wanted to like make a request to some, Google.com and get search results, you could use this module to make that request, get the content, and make some, you could write a web crawler that searches the internet, grabs HTML pages, and stores them in a database. So now you can make your own search engine or something with this module. Okay. Now there are better modules for that are already better to be like, hey, this is a crawler. Let's look at npm. Web spider. Yeah, here you go. Crawler is a web spider written in Node. Right, so it's for scraping web pages. Much easier. Lets you queue in pages to go read. But if you wanted to write your own module, HTTP will let you do that. Any questions? pretty happy with this little light switch page. I need to make something that has a server like this that I can turn stuff on and off. Very happy. Cool. All right, let's let's play with Express now. Okay. So Express is intentionally built to be a better web server framework for deploying web applications, right? They took that HTTP module concept and said, this is a pain in the butt to write this kind of code. Let's make it very easy for us to build web applications. Express is not the only such module. There are hundreds of modules that try to do this same sort of thing, but Express is one of the better ones. It's been around since the very earliest days of Node. It has the most support behind it. It is very robust, very well tested. It is a framework that lets us... It has a whole bunch of other modules that are like optional, right? So you can use Express and you can turn on special types of routing. You can use special types of templating, right? So we've been writing HTML. Express will let you plug in a templating language like EJS or Jade or Smart Templates, right? There's all kinds of things that we can do with Express because Express is a framework that lets you build web applications. There are lots of modules. We're only going to scratch the surface of what you can do with Express, but just be aware that the Express-based ecosystem is huge. If we were to go to NPM here, let's see. Let's just search for Express. Right? This is the specific module, but then you can see cores. This is middleware for that. Express style stuff. Express JWT is authentication module, so you can just plug this right into Express and get authentication. Handlebars, this is a template engine for Express. Here's turning on file uploading. Like all this stuff works with Express. So when you use Express, it comes with this big ecosystem of people contributing modules that make it easier to work, to work and get stuff done. Okay. It tries to be unopinionated, and what that means is they provide a mechanism for you to do work, but they try not to force you down a certain path so that you can use it for any and every project, not just specific ones that fit some worldview around Express. Like the HTTP module that we just took a look at, all of their callback functions that handle requests always have that same sort of structure where you've got a request object and a response object that are passed into the function. And we'll talk about middleware and some built-in modules when we start playing with this. Some of the middleware stuff is like this JWT or cores, where what this does is it lets us write code, right? So maybe I can show this off as an example. Right? So here, right? So this is our function that runs on each and every request with the HTTP object. What middleware does is it says, okay, I know that I'm going to write this code to handle the request, but before this code runs, do something else. And so what Express gives us, Express has provided module developers and us with a mechanism to call functions that always run before the actual function, if that makes sense. So what you can do, and the reason all those modules that we were just looking at in NPM work, is that we're going to write our code to build our website and to handle all of our requests. We're going to turn on a bunch of Node modules that happen before those requests. So every time I make a request to the page, it's going to check to see if I'm logged in. Every time I make a request to the page, it's going to make sure that I have the right cookies. All of that is called middleware, where it sits in between the framework, the requests, and the response. So all of the stuff in the middle is middleware, is what it's referred to. Okay? Any questions? Go ahead.
So middleware, that is just making sure that your functions or whatever that you will call has the right parameters in place, or is that?
Kind of. It's making sure that it doesn't make sure anything. It's just an option. So when the request, we'll use this HTTP as an example, right? This server is listening for requests on port 8888. Every time I request this page on port 888, this function here is going to handle that request. What Express has done through the concept of middleware is that we can write code or use code from node modules that we're going to install that every time a request comes in, before I get to my code, it calls some other function first. So we'll be able to set up our own routers. We'll be able to set up authentication. We'll be able to set up, API layers, right? So if a request comes in and here's an example. This is all these requests. If we were to look at the request object here, it lets us know, hey, I'm in a Chrome browser and I'm asking for HTML. Okay, that's what the browser is setting behind the scenes. I want HTML to come back. If we were to use the XML HTTP object, the XML HTTP object is going to say, I'm making a request to this server. I'm JavaScript. I would like JSON to come back. What middleware will let us do is write this code to handle that request. But the middleware sits in between this function and the other function and says, hey, this is JavaScript that's asking for this. Please send the response back as JSON instead of HTML. Middleware just sits in between our code and the request. And I'll try to point this out when we start exploring with Express, because middleware is such a big concept, because it's like, it can be an authentication function, it can be stuff we write ourselves, it can be a template engine that generates HTML for output, it can be a database query. Middleware just is in the Express context, it's a place where we can define functions that run in between the final function and the initializing request. Okay. Go ahead, Kareem.
All right, so putting this in a way that I can understand, HTTP mode would be a manual transmission car, whereas Express would be an automatic. You get what I'm saying? You don't have to change the gears.
I do.
With
I think HTTP is more like a bicycle, and Express is more like a Ford Motor Company factory. It's building trucks, engines. You can build, it's got Mustangs in there, right? Like what we build with Express, because it's unopinionated, it lets us use any kind of vehicle we want. HTTP
so it's
module,
more powerful.
Yeah, HTTP is a transport mechanism. We're going to get on a bike and we're going to pedal and we're going to make a request to the server and everything's great. The Express module is going to have everything HTTP can do, but also we can turn that into a Mustang, or it can be a Shelby, or it can be a Cobra, right? Like, it can be whatever we want it to do, but it's still a transport module. Express is a framework for letting us build it however we want.
Got it. That makes sense. Okay. So the Express is extremely powerful, in other words.
And at the very bare minimum of what Express can do, it's going to end up looking very similar to this code. So that's why we introduced this first, because this function style where it says the callback has a request object as the first option and a response object as the second option argument, is Express uses this exact same pattern. Okay, so let's build an Express project. Open folder. And I'm going to make a new folder. And I'm going to call it Express. Okay. I can't call it Express because we're going to use Express. Express project. Okay. So now I'm in a brand new project, brand new folder. So I'm going to come in here and I'm going to make I need a terminal. Right. We need to run npm init. Okay, great. Express project, version 1, description, cool. Yeah, that's all fine. Eric. Nice. Perfect. So we're all set up. We got a package JSON. Okay. Now Express is not a built-in module, so we have to run npm install Express. Okay. It's pulling that package from npmjs.com, and you'll see now, this is about the complexity of this, right? Express, which is right here, this requires accepts, which is telling it about what type of content the browser is requesting. Body parser is how it reads form data. Cookie stuff, cookie signature, content type, so it can respond back, hey, this is application JSON, or binary PDF or whatever. All this stuff in here is required by just the default of Express to handle all the complexities that we're going to build in here. You don't have to know about all this. Express is doing a lot of this behind the scenes, but it lets it be ready to be like a really robust web application and web server for us. So I'm going to make an index.js so we can start playing with Express. So this starts kind of similarly to how the HTTP module did. And do I still have that code open? Probably not, right? Nope. Here, I'll just open that folder. Open, what did I call it? HTTP? Something? HTTP object. Perfect. So I just want to show off, right? So this is, right, how we do things in the HTTP object module. So express is similar. Const express equals require express, right? That creates the class that we're going to use to build our app. Then we say const app equals express. Okay, so it's not a class constructor. We're not saying new express. It's not a class. It is just a function that returns an app. Okay. Then we would say app.listen, and we give it a port. 8080. Let's do 8888. Good. So right now, if I was to, this should hopefully work. Let's see. Localhost 888. Right? That is, yeah, so we don't have, it's not doing anything there. So let's actually write a route. So with Express, we have to write routes. Remember when we were looking at the HTTP object? One single function handled all the requests. Okay, and we would go in there and grab the URL. With Express, we define each of these routes separately. So we'll say app.get, and then we'll say /. Okay, and then the function is the callback that has a rec and a res. Okay, and so then here we can say res.send hello world. Okay, and if we we need to run our app node index.js. Good. So right now the server is running, and if we go to 8888, we see hello world. Now if I went to /user, or what do we have as before? Switch, right? It's going to say cannot get switch because our request, our app does not have a /switch route defined. Okay, all we have defined is when a request comes in for /, like no page asked for, give it the send this response. This should look pretty similar, right, to this type of thing. We're saying, so here we're saying res.write in the HTTP object, we're saying write this output, res.end. With Express, we're saying res.send. And as soon as the function ends, it's automatically closing that connection. So if we wanted to replicate that switch concept that we just built, right? Let's make this, we'll say let switch, let light switch equals off. Okay, so the default route says hello world. That's fine. We'll just leave it for now. So I'll say app.get switch function rec res, and then what we're simply going to say here is if let's switch it, right? Light switch equals light switch equals off, on, or off, right? We're going to use ternary again. And then we'll say res.send light switch. Okay? So now I have written this light switch, this switch route that will do what we were doing the very first time, where it's going on or off. Okay? And so if I was to come into my server and I call switch now, it says on, off, right? Just like before. Okay? If I wanted to do what we were doing previously and I wanted to write 3 separate routes, I could say app.get on function rec res, and then we'll say light switch equals on res.send light switch, and then we want to do the same thing for off, app.get off function rec res light switch equals off res.send light switch, and put a semicolon. Good. So now if I reload our server, right, on off, that's working. If I go to on, This route is always going to be on. I'm hitting Control R, right, or reload. If I go to off, it's always off. And if I go to switch, it's going to switch whatever it was. So we've written a program now. This program is always running while this app listen is in place. So this server exists just like the previous server did. You'll notice this is still running down here. And we define our routes, R-O-U-T-E-S, routes. These are the routes that this server is going to respond to. So /switch goes to, if I go to /switch, it does this line of code. Turns it from on or off, and then it sends back that value. This is the tip of the iceberg. Does anyone have any questions with this? What do you think the .get here means?
It's a GET request, right?
Exactly. Express lets us define our routes based on what method is being sent to this, right? So I could also write a app.post, and we'll call it switch, function, rec, res, right? And maybe this does something different, right? Maybe if I post it, res.send, you broke the light switch. Okay. And so if I restart my server, okay. All right, this is the GET request. If I was to go in here and make an XML HTTP object so that I can post this, let's say var xhr equals new XML HTTP request, okay, and I say xhr dot open, and we're going to say post, and we'll say switch. Oh wait, I have to say localhost 8888 switch xhr dot on load equals function this dot contents this dot what is it text content, right? That's not right, is it? Shoot. XML HTTP request. What is the response text? Yeah, response text. Right here. This dot response text. Let's log this to the console. Okay. Good. And then we do xhr.send. And if we were to look at the network tab, right, well, you can see it logged. You broke the light switch. And it said a post to show here. Type no, probably in here. Yeah, so we're making a post to switch, and the response was you broke the light switch, exactly like we defined. So when we're building applications, right, what we'll generally do is, let's say we have a user object, right? I'm a user. I'm logged into your page. /user/Eric is me. And so we'll write something that says app.get /user Eric. Function rec res. Okay. So, res.send, this is your user ID. We make it like 1. Okay. Or let's do this. We'll show this off. I'm going to use a template string, and I'm going to put in here a variable called user ID. Okay. So let's make a user ID variable. Let user ID equal 1. Okay. So this is the get. Okay. If I do the post, we're actually going to store the data. And maybe we'll do post, and then we'll do new user ID. That's fine. Okay, function rec res, and we say user ID equals rec dot. What is the let's see, what is the express variables in URL. Rec.params. That's it. Rec.params.new user ID. And then we say res.send your new user ID is plus user ID. Right? So we'll use the post for letting us update our user information. User error. Okay. So this is my user ID 1, but when I post to this with this URL being changed, right? So let's do it again. Let xhr equals new XML HTTP request xhr.open post. We say HTTP localhost 8888 user Eric, and I'll make it 13. Okay, I'm gonna post to this route and tell it that I'm passing in this variable. Right, that's what this code does, and we'll spend more time just showing this off as like a, hey, look at what we can do. Right, so we're saying, hey, we're gonna pass something in this URL that we want to grab as a variable. That's what this line of code is doing, and then we're gonna change that that variable in the server to be this new thing, and then we're gonna respond back with your new user ID is this. Okay, that's all this is doing. So if we run this code, and then we say xhr.onload equals function console.log. Yeah, let's just respond with the response text. Then we do xhr.send. So you'll say your new user ID is 13. If I run a GET request now on /user/Eric, my user ID is now 13. We've just changed something on the server. Now, when we introduce databases in a week or two, like this is how we do things. We're going to post to a page. We're going to update some content. When we send variables to our server, we're going to grab all those variables, store them somewhere, and now we've got, a new blog or a new roast for your coffee, or when I'm smoking a turkey for Thanksgiving, I'm going to put in, this is my smoke time, this is my smoke temperature, this is the brine I put it in, and then I can rate it. I can have everyone at the table, go to that page, /cook /52 is that turkey that I just tried, and everyone can rate it. 5 stars, 4 stars, 2 stars. Okay? Any questions about Express?
So this is different than we were saying, like the app.get is different than the HTTP module.
Yes.
It was, what was it set? What was the send?
Yeah. In HTTP, you do
write.
res.write, and then you have to manually say, hey, this connection is over. Res.end closes the connection.
So to understand that in Express, is that just all in the documentation off of NPM? How would I, if I'm, first time doing this?
Yeah. So let's dig through it together as if I didn't know anything, right? I would come to NPM and maybe I would look at Express. Now, Express is such a big framework that they actually have their own website, right? This is such a, I would probably say 50% of all Node projects are probably doing something with Express, right? Because this is how you do things in Node for the most part for web development, right? So they've got their own guide, getting started, right? Hello World is going to walk you through those sorts of things. There's so much complexity here. I haven't even scratched this, and this is me. I've been doing this for 10 years since this came out or whatever. There is so much power behind the scenes here that I haven't even scratched the surface of this. But they walk you through how to use some of the templating languages. We're going to use all of this over the next couple of weeks, and so we'll slowly start to introduce more and more complex things with Express. Express, their documentation just from NPM, is going to kind of give you a quick start guide a little bit. But they have other links in here, website and documentation. They have a chat system if you wanted to hop on IRC, for those of you who know what IRC is. They have a wiki. They have a Google group. It's a big project.
So is Express a private company, or is this just an open source project?
Source project, yep. And let's see who. Maybe it tells you. Let's go to their wiki page. Visit the wiki. Maybe here. Yeah, I don't know who originally made it. Let's maybe see Wikipedia. Maybe they'll have history here. Express JS. Okay, there we go. Is a web application framework, releases free and open source. Yeah, it's under the MIT license, so it's completely open source. It's just a project for people. Like, almost all the stuff in NPM, at least like the big things, with the exception of modules that are very specific to a company, most of it is some software engineer got sick and tired of using the HTTP object to build like a web server, and we're like, I'm gonna build a better one, and they made Express. And it probably started off very small. If we look back at the very first commit, it was probably just a very thin wrapper around HTTP. And then as more people started using it, right, because it's just source code, any software engineer is like, this is great. It would be great if it could do authentication. And they would go and write that piece of functionality. So the world gets to be a better place because software engineers like to contribute and like to make things better. And if we were to look at the GitHub repo, which is, let's see. Right? These are all the open issues, right? These are like, how do I do this? This fails in this condition, right? Like, this is open source. You can go in here, you can, just like with everything else, you can read this. You know, if you wanted to be a contributor, right, you could read this and be like, I can fix that. And then you would fork the repository and open a pull request. Like, there's 61 pull requests in here from people that are contributing, trying to make this a better project. Okay. This is the beauty of open source, right? The internet lets every software engineer all over the planet that cares about this module to make improvements. Like, I could release this paper, rock, scissors thing as like a one-stop shop class for a one-stop shop module to add paper, rock, scissors to your game. And, you know, if Josh wanted to contribute to it and he's like, I got a better algorithm for the computer to be better at beating Eric, right? Like, submit a pull request, and now my module gets better. That's all this is just momentum of people contributing and trying to improve this project, right? It does have an author. Whoever Express.js is, like whoever owns the website, is probably, if I had to guess, is probably the first guy who made it. Or maybe it was taken over by a maintainer. Yeah. So right now, Express is a project of the OpenJS Foundation. So whoever that is, like, they're responsible for being the maintainer of this. They probably provide some contributions monetarily. They probably provide some marketing. I bet they probably run a course. Yeah, they have a certification here. I've never heard of them, but they look pretty cool. All right, any questions? Okay, it's 6 o'clock. Let's take a break. Then we come back. We're gonna have everybody build something in Express. Start the recording again. Cool. So I'm gonna go to GitHub first, right? I want to do the paper, rock, scissors module. I'm gonna build a web interface for this. So generally, when you're working in like an office environment, you're on a team or something, right? You'll have a class, like the paper, rock, scissors class, that will be its own repository. And then you know that you're going to build it as a web app. So what you'll often see is you'll see a paper, rock, scissors, and then it'll maybe be like web, right? Or server, right? So it'll be two separate repositories, but it will be named in such a way to let you know that, like, hey, this is the server that uses this other class. Okay? I'm going to add a gitignore node, create a repository, then I'm going to copy the code and exit out of here. I'm going to do git clone, paste this in, good, and then I'm going to open this with, all right, I'm going to leave the class open in case I needed to add more functionality to it. But what I'm going to do is I'm going to open that project folder, paper, rock, scissors, server, right? This is the server we just created, this repository. Okay, so just like with everything else, I'm going to start this off by saying npm init, right? Paper, rock, scissors, server is perfectly fine. Version 1, entry point is going to be index.js, that's fine. It's got a git repository, excellent. I'll type my name in here, okay? So we're all good. So I've got a package JSON now. Now I know this is going to be an Express app, so I'm going to do npm install Express. Okay. Then I'm also going to do npm install code boot camp 13 paper, rock, scissors. Right? So I can have that installed, that module that we're building here. And then I'm going to create my index.js. Index.js. Okay? So, right off the bat, I'm going to do const express equals require express. Then I'm going to do const app equals express. So that creates the server is going to be under this app object. But I also want const paper, rock, scissors equals require paper, rock, scissors, right? I need to pull in my class, and because this is a class, right, it shows up as like this dark green color, letting me know it's a class, I have to initiate it with const PRS game equals new paper, rock, scissors. Okay, so now we're all kind of set up. Go ahead, Josh.
So why isn't Express a class? Is it just be? I guess I'm a little confused.
Yeah, Express predates ES6.
Okay.
So this has been around since the very first version of Node. The way we built classes way back in the day, if you remember, we didn't even talk about this, right? We used to just write a function that would be like Express, and then we would call this by saying var e equals new express, right? So the new keyword would make an instance of a function. Classes like we just wrote with this version is ES6. That didn't exist when Express came out, so the way that they implemented this function, and this is one of the problems. This is why I said get super comfortable with documentation. Express was written by somebody who had an opinion. They said, this is how I'm going to write my library. This is how my framework works. They could have made this a class, but they decided they wanted to have a function that returned an app object. So you just do what they tell you.
So it is a little bit arbitrary. Like you just got to read the document.
100% arbitrary. Everything in programming, there's like 70,000 different ways to do things. It's up to whoever's writing the code to write it in whatever style they choose.
Okay.
Cool. So with Express, right? To make that be a server in the first place, I'm going to say this is on port 3000. Just because I like it, right? That actually turns on the server, but we want to define some routes. And so I'm going to say app.get/ function rec, and I'm going to use ES6 functions because I like the way they look here. So I'm going to say rec, res, okay, arrow pointer, and then what we're simply going to do here is say res.send paper, rock, scissors. Okay, great. And maybe we'll even leave a to-do for ourselves of, like, think about making this page interactive with buttons and stuff. We'll get to that, okay? So I need to make 3 routes. I need a paper route, a rock route, and a scissors route. So, same exact thing. App.get paper, rec, res. Okay, and then in here I'm going to say PRS game, I'm going to do res.send, and what I want to send back is the return of PRS game.paper. Okay, so all I'm sending back is win, loss, tie by calling paper. And I'm going to do the exact same thing for rock and scissors. Okay, so I'm going to change this to rock, change this to scissors, and then rock and scissors. Scissors. Okay. So if I run my server now, node index.js, and I open this in localhost port 3000, paper, rock, scissors. If I go to paper, tie, I go to rock, tie again, and scissors. Hopefully we'll, we got a win finally. Nice. Okay. So that's the first part. That was what we said, hey, let's try to get this accomplished, right? We did this with 15 real lines of code because we have all of our cool functionality inside this module, right? We wrote the game. Now we can build a server that takes advantage of this game, right? Just by simply sending back the result of those functions. Okay? Now, what else does our game object do, right? We have the ability to get statistics, right? So we know we have a result object that tells us if we won, what percentage we won. So let's make a app.get, what do we call it? We'll just say win. Okay, and we'll do rec, res. So if I wanted to get my win percentage here. Maybe I would do res.send prsgame.win. Okay. And let's, okay. So now is the stage where we start to get a little bit clever, right? So I wrote this line of code. I have to stop my server with Control-C and start it. So now would be a stage where I would probably have done this to begin with. But what I'm going to do is I'm going to show you guys a little trick that I love, right? So I'm going to npm install nodemon. Oh, actually, I'm going to cancel that. I want to npm install nodemon as save dev. So it's only installed for the development mode. Okay. And if we were to look at our package.json while this is doing it, right, it's adding this nodemon as a dev dependency, developer only dependency. What I'm going to do though is I'm going to come in here into the scripts tab, and I'm going to say dev colon. I'm going to say nodemon index.js, right? And what this will do is if I run my program with npm run dev, it's going to run that script, which is running nodemon index.js. And so as I make changes to my program, it is going to reload that server. So I don't have to keep stopping and starting it all the time. That drives me crazy. So now it's starting index.js, right? I can verify it's running, okay? But now I want to check my win percentage. Okay, 71% of the time I win. Now what makes Express especially powerful is that we can write routes that have extra parameters that go directly into a variable for us. So if I say win paper, I want that route to take paper and pass it to this function. So here's how we can do this. This is kind of some magical stuff here, right? So I'm going to use a slash here. Okay. And I'm going to, so that's the default. I'm going to do app.get /win, and then I'm going to put a slash. I'm going to use a colon, and I'm going to say choice. I can put whatever I want here. This is going to be the name of our variable. So it's colon and then a word. And when we do this, right, we do rec res inside. Okay, I lost my curly brackets. Inside the rec object, rec is a params object, and that params has choice in it. So anything that we put in here as a colon, right, we can have any number of special variables in the URL path here. We can, whatever we call it up here, it will be created as a variable inside rec.params. So I can say let choice equals, okay? And if you remember when we built this win function, we said, hey, it optionally will take paper, rock, or scissors and return the win percentage of that element, right? So I can say res.send prsgame.win choice. Okay. And so now you notice because I just saved this code, it restarted this server for me automatically. Now if I come in here, right, win paper, it says not a number. So we have some problems in our class where if I say what's my win percentage and I haven't played any games yet, right, it's trying to divide by 0. Like it's trying to do illegal math. But if I was to come in here and say paper, loss, I run paper a couple times, then let's run rock a few times. Okay, good. Let's run, what's the other one? Scissors. Run that a few times. Good, good, good. So let's look at our overall win percentage. Overall, we've won 27% of the time, which is kind of to be expected. That's getting close to statistically regular, right? But if I do win paper, I've won 28% of the time. Let's check rock, 25% of the time. And scissors, 28% of the time. So we've just in, 5 lines of code implemented that statistics page. So we want to do the same thing for loss and tie. So loss, tie, tie. And then here we do loss, tie, tie. And as soon as I save, you'll notice the server will restart. Okay. Now, if I call win scissors here, what do you expect is going to happen as the result? Or let's change loss. Loss scissors. What kind of value do you think we're going to get back here?
You should get you should get a percentage, right, of whatever you're losing percentage when you pick scissors.
Okay. We're actually going to get not a number. Do you know why we're going
It's
to get not a
just
number?
because we haven't run just the scissors game to get the percentage of losses.
So what I'm showing off here is that I just added these extra things. So the server restarted. When the server restarts, it creates these apps. So this PRS game variable is just now created. So all of the stuff that was in there from my previous result is gone. So I would have to run it again a couple times. Scissors. Right. Okay. But now we can check loss. We can check. Oh man, we're doing terrible with scissors. So we've lost 9% of the time. Tie. We tied 63% of the time. Computer likes to pick scissors, huh?
So if we wanted to save this is where our
database comes into play.
Database. Okay.
Yeah. Or, if we don't know about databases yet, we could use the file system and write this to a file. That's kind of like the very earliest versions of databases were just people writing stuff to files. So we could do that here.
Okay.
There's also node packages. There's like SQLite, or there's like persistent storage that writes a file for you, kind of like local storage does, where you can just say save my information and then get my information. It will write files behind the scenes. But we're going to learn about databases next week or the week after, and that's what you'll be using in your for the rest of your careers, like for the most part. And that's pretty much it. There's one last thing I want to show off, and this is going to introduce the concept of middleware. This is the last thing we're going to look at today. So this is all what we would call like the dynamic code. Okay? So this is like the stuff we're writing that like the user has chosen something, we want to do something behind the scenes with some JavaScript. This is like our bread and butter, right? Now, obviously, we're not going to just send single word web pages back most of the time. But we've spent a lot of time learning about HTML and CSS. How would we build that in Express? I'm going to show you, this is the concept of middleware that we were talking about. So these are all the routes that we've defined ourselves. But what if we wanted to have like an HTML template file or something in here, right? Let's make a page1.html, right? Like, how would we serve this page, page one, in page one, right? We build this full template with a design, everything's pretty, and everybody loves our page, right? If we're using Express. Well, there is middleware here. So at the top of our code, we can say app.use. And so the app.use function is going to say, for every request, do something. Okay? And this function, right, a whole bunch of modules will say, hey, the way you use this module is you're going to say app.use whatever, and they'll tell you how to use it. But there's one built-in one that lets us load HTML files, and that is express.static, which is a function. And the function itself takes a folder name. So in this case, we'll say like public, right? Without a slash. So what we're saying is, hey, for every request, check inside a folder called public to see if a file exists. So we're going to make a folder called public. Public. Okay? And I'm going to move this page one into that page. Did it go in there? Refresh. Page one into that page. Yes. Move. So now I've got page one inside this public folder. And if we run our code here, right, all of our scissors stuff still works. Paper still works. Okay? But if I go to page1.html, it loads that page. Okay? And we can put anything we want in here, right? We could put a folder in here called CSS, and we can make a style.css, right? We could say something like body, background, color, medium turquoise. Cool. And then this page, right? Link rel equals style sheet. href equals css style.css. Okay? So from the point of view of Express, when we said, hey, use this middleware, Express static, treat this folder public as if there's a file in there. Right? So public is the public folder, but then inside of it is a /CSS and a style.css. Treat that folder as if it was servable. So we're going to put all of our JavaScript, our front-end JavaScript in this folder. We're going to put all of our CSS in this folder. We're going to put any HTML templates we build in this folder. It's going to let us build like a beautiful page and then have dynamic stuff happen behind the scenes. We've built like a full-featured web server, right? And so now this page is turquoise. But yet still, Scissors is still a page that works. So this is middleware. This is what we were talking about earlier. It sits in between the request and all these different routes, right?
So why isn't, when you go to the scissors page, why isn't the background blue?
Because all we're sending on the scissors page is the text prsgame.scissors. So if we were to look at this page and we view page source, it's just saying win. That's all we're sending back.
Okay, so the middleware doesn't. I guess I'm still a little confused. So the middleware is what is actually all the front end stuff, is all that is?
No, the middleware is literally just software that sits between the request and the end of the request. So in this example, we're saying, hey, because if we went to some page that didn't exist, something, right? I'll do it from here, right? Express knows, hey, you requested a resource. We have not defined a route for it, and there's no file that exists in that public folder. So it's sending you a 404. This is like an error handler, and it's saying, you cannot get this resource. It doesn't exist. The middleware is sitting in between there and saying, hey, if I know about this file, even if you haven't defined a route for it, please serve it.
Okay.
We're going to have a whole bunch of other middleware that says, hey, before this request even goes through, are there any cookies? Can I look up in the database to see if this cookie associates to a user? And if so, authenticate him for the rest of this request.
Okay.
The static middleware is like the most lightweight version of this, because what it does is it says, hey, this express static, if you go look up the documentation, it's saying, if I find this file, stop worrying about the rest of the request and just send it out to the user. Right? We use this for JavaScript, CSS, images. We don't want JavaScript caring about like what the image information is. We don't need code in here telling us that if the user has requested a file that is in this folder, we just send it out and be done with it. Other middleware will take this request, do something with it, and then pass it on so that it goes to the next step. Express static does not. It just says, hey, it captured the step, end. Right? If I was to come in here and say app.get, and we say, what do we call it? page1.html, right? Ooh, got to give it a slash. Huh? So let's see what happens here. Function, rec, res.send inside the page1 request, HTML request, right? Let's see who wins. Let's say page1.html. Okay. You'll notice that that piece of middleware, express static, is sending this out and not even letting this go to this route we have defined. Because that's the entire purpose of that part of middleware. It says, when the file's there, just be done with it. Send it out. Whereas other middleware will do something in between and then pass it on to any defined route to let us finish it out. When we start getting into templating, we're gonna learn about templating next week. I think we're gonna use EJS in this class. The templating engine will be similar to this, but it will load a template, and we'll be down in here and we'll say res.render. So our middleware for the templates is gonna like fetch things out of the database and then call a template and plug in all these variables on that page.
Okay.
And we'll get to that for sure. So
your middleware, you want it to do, like, is there like a default that you want it to, like a standard, like, hey, always display this type thing, or?
We'll cover that when we get to templates.
Okay.
Which will be next week. Right now we're going to focus on just the fundamentals, right? So what we would probably do, right, instead of handling this / request, is that generally, if we were playing with how we were building things over the previous couple of weeks, right, we'd have this actually be renamed, and call this index.html, right? So that page is going to be the same as /. Okay? And then instead of this being paper, rock, scissors, okay, we will load, let's just kind of walk through this, right? So when I go to / now, this is index.html. It's serving that static file. Then there'd be a bunch of buttons in here, and those buttons would use XML HTTP request to send API requests to our server at these routes: paper, rock, and scissors. Right. So if we had a let's come in here, right? So let's do a button. Input. Let's do a button. Button ID equals paper. Paper, button, and we'll copy this. Oh, copy. Okay, rock, scissors, rock, scissors, and then maybe we'll make a div ID equals results. Right. Cool. So let's make a JavaScript file real quick. Script type equals text / JavaScript. Source equals JS. Paper, let's call it prs.js. Okay, good. Okay, so I'm going to make a static file in this public folder. Make a folder called JS. I'm going to make a file called prs.js. And we need to make this deferred. Right, we have to have this load after the page is done. So what I would do is I would say document.getElement by ID paper dot add event listener click function. Right. So when we click this, we want to send a request to paper to see if we win. Okay. So same thing, right? Let XHR equals new XML HTTP request. XHR.open get and /paper. XHR.on load equals function. And inside of our function, we want to document.getElement by ID results. Right? Was that what it was? Yeah, results. Dot inner HTML equals this dot response text plus, and we'll just copy what used to be in there before, right? So we'll have like a list of all of our responses, and maybe we'll put a new line in there so we get a space between each of these. Okay, and then we'll do xhr dot send, and so I want to do this for all 3 of those buttons. So we'll do paper, rock, scissors. Okay. And so now, load the page. I've got this paper, rock, scissors button. If I click it, it's making a request. It said I won. Makes a request. I won again. Oh man, I'm crushing it with paper. Now I'm playing some other things, and you can see inside of our developer toolbar what we're doing. All right. I click paper. It's making a request to paper inside of my application, and it's responding with win. So the page itself is loaded from an index page, and then all the cool stuff is happening dynamically with XML HTTP request object. Okay. So this is one way to build websites, web applications that are dynamic. Now, I don't do this type of project really at all. Most of the time, I'm building a really complex application where all of the cool stuff is happening server side. And by server side, I mean I'm actually writing code in here so that when I get a page route, it is loading the page fully. And the reason I do that is so that this page will work even if my user doesn't have JavaScript turned on. That's my biggest concern. JavaScript, to me, is always best when it makes the experience better. This should work regardless of if I have JavaScript turned on. But if I have JavaScript turned on, then as a nice feature, I can do it without a page reload. So, we're going to learn about templating frameworks. There's a really good one called EJS. There's another one called Handlebars. There's another one called Jade. There's a whole bunch of these that work for Node, where it's just a different syntax. It lets you write HTML, and then in your HTML, you'll be able to pass it variables and say like results info, right? And so inside of your routes, you'll be able to say, hey, call this template, and here's the value to put in that results div, that results variable. And we'll definitely spend tons and tons of time dealing with that next week. Because that's really the best way as a professional to write good code. Okay, but now we've kind of gone full circle. We started with a paper, rock, scissors game that we built just in JavaScript as a web page on the front end. Now we've introduced a server concept, and we've shown how we can build this to be dynamic. Well, really like the last step of taking this over the edge would be like, okay, let's design this page to look really good. Maybe we'd make it so that each of us have individual user accounts, so I could track my wins and losses versus Josh. Maybe we make it multiplayer so that I make a choice, Josh makes a choice, the server tells us who won between the two of us. Like, the sky's the limit with programming now that we have servers involved. Now that we've got something, a physical infrastructure that sits in between my computer at my house and your computer at your house. We can make multiplayer paper, rock, scissors, and we can see 5 people going at the same time, see who wins. I don't know. Eric beats Josh, Josh beats the other Eric, Olivia beats everybody. I don't know. Cool. Any questions about Express? We're gonna continue playing with it. This is our server technology for the rest of this course. There are others. We're just teaching you one. Any questions?
No, but it's starting to make sense. So little, bit by bit, it's coming together. So
good. And hopefully you're starting to see how writing one good class has let us build a web product very easily, because we're gonna all the logic is in that paper, rock, scissors class. Right? All of our statistics and all that. We built this in 40 minutes this afternoon. And now we built a website in 30 minutes that uses that class. It's an ugly website. We'd want to spend time styling it and make it look nicer. But we have a working implementation of a full game in less than an hour and a half. And I'm obviously fast. I'm a fast typer. I know what I'm doing, so I can breeze through it. But you guys should be more than capable of getting to this stage where someone says, hey, build a paper, rock, scissors game for me. You should be able to do this in an hour, tops. Cool. All right, so the homework for tomorrow is not going to be assigned. It's not something that's tracked or graded. What I want you to do during lab time up until 3:30 is I want you to build some kind of Express app. I don't want it to be super complicated. I want it to be something you can accomplish in 2 hours, where it does something, right? Maybe it's a recipe picker for you, Josh, where you click a button and it randomly picks, hey, you're going to smoke turkey for 2 hours and brine it on whatever. And for Olivia, just be creative, right? What we're hoping to see here is a little bit of creativity. We want to start tomorrow after our guest speaker with a little bit of show and tell. We want to see what you built. It should be a full featured, it does something in Express. I don't care if it doesn't look pretty, have it. We really care about the code at this stage. I want you to show me, here's the 4 routes I built, here's what this route does, here's what that route does. Do something interesting. Okay? Go ahead, Eric. Or Bernard. You're muted.